A manufacturing machine has a 9% defect rate. If 9 items are chosen at random, what is the probability that at least one will have a defect? So the probability of success here, which is choosing an item with a defect, again, I can't emphasize enough that probability of success does not mean a positive thing, nor the probability of failure. So for example, here the probability of failure is not choosing an item with a defect or choosing an item that doesn't have a defect. So the probability of success here is 0.09 or 9%. And then the number of trials is 9. That is the sample size. If you choose 9 items, what is the probability that at least one of them will have a defect? So the first step that we're going to do, we're going to build a binomial table. We have the number of trials is 9, which means the possibilities, all of the possible outcomes are 0 items are defect, or 1 of them are is defect, or 2, or 3, or 4, or 5, or 6, or 7, or 8, or 9, which is all of them are defect. Now we have all of the possible outcomes. Now we need to find the probability of each of these possible outcomes. So we're going to use binomial distribution function to compute the probability of each of these possible outcomes. I'm going to click on the 0. I'm going to begin with the 0, comma, the number of trials is 9. The probability of success is 0.09 in my question, and then false. Or I can just type 0 for false, because I want to compute each of these probabilities for the possible outcomes individually. I don't want to accumulate them and add them together. Now, I will do the same for 1 and 2 and 3 and 4, and I can do that easily with Excel if I populate the table. Now, the question is asking, what is the probability that at least one will have a defect? That is the same as saying either 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9, because it says the least is 1, but it could be more. So since I'm saying or here, I have to add all of these probabilities. So I will add everything here using the sum function. We said at least 1, so we're going to begin with 1 and go all the way to the last probability, which is the probability of 9, and that is going to be our answer. I'm going to copy that and paste it to my answer box and submit the question. So this is how you answer at least for a binomial distribution question.